All right, everyone. We are now getting inside our module number 4 that is going to be compute section. So what are our compute options in GCP? Where we have compute engine, those are virtual machines, containers, container orchestrator, Kubernetes, VMware on GCP is there, bare metal servers, app engine and a few more services, right? So, and we're going to couple of more small things around compute, in this module itself. All right, so let's get started. All right, so we will get started with compute engine. Compute engines are nothing but virtual machine offerings in GCP. There are quite a few choices and they work along in sync with other Google services. Let's look at them in the console once. All right, so we are inside the compute section, and I just wanted to show the compute options that we have. We have general purpose, we have compute optimized, we have memory optimized, we have storage optimized, and we have graphic processors, that is GPUs. Now, if I look at which is the biggest option of machine in compute, so I can see 112 vCPUs over here, and I can go down over here and see that I get this VM with 112 vCPUs and 224 GB of RAM. If I need more memory in comparison to CPU, which it is offering over here, I can go to high memory and then I can select a high memory machine, which will give me 112 vCPUs and correspondingly 896 GB of RAM. So a lot of options are there in terms of combinations. And let's look at what is the largest possible memory which we get over here. Wow, that's 32 TB of memory what it offers us. That's a really lot of memory. Last thing which I want to highlight is under general purpose, I get this unique option of custom machine types where I can customize the number of CPUs with memory. Okay, so I can select over here how many CPUs I want and corresponding amount of memory which I want to use. So, okay, let's say I want to maybe use 7.25 GB of RAM with 4 cores of CPU, right? I can create this custom machine type. So, this custom machine type is an offering which I believe only Google offers and it's not there with any other cloud provider. Next, we'll talk about quotas. Now, when I tried to select a few VMs, right, I was getting a message that this is not in my quota, and quota basically is a limit, which is a software limit where I can cut a ticket and I can ask to increase that limit size. They are maintained to control runaway resources. So just imagine that when if my account gets compromised and someone launches hundreds of VM, who will pay for those? Or hundreds of GBs of memory is used, without your approval. What will happen, right? Who will bear the cost of such events? So all cloud providers maintain a quota. Quota is a soft limit, as in when you consume, you can always cut a ticket to Google and ask for more quota, and they will keep increasing as your need increases with time. But there's a cap which it maintains always to limit the amount of runaway resources that are possible. Right? So that helps to control the billing part of things. All right, let's move on to the next compute. Let us understand pricing component of compute engine. Almost like everything else, it is also on demand. That means you pay based on the consumption that has happened. So if you're using a VM for 1 hour, you pay for an hour. You're using it for 5 hours, you pay for 5 hours. And that all pricing falls under on demand. Now, for those applications which are going to run for a longer duration, your website is now running on GCP and it's going to run on a database and a compute engine. So you need that for a period of maybe 3 years or at least 1 year commitment you are ready to give. So moment you say that you are ready to commit for a longer duration, you can go ahead with a committed discount. Here you are kind of entering into an agreement to use that for a longer period, typically 1 to 3 years is the duration for it. And because of it, you get a discount since you're committing for a longer duration, and the costing comes down as compared to on demand. Now, we'll talk about sustained discounts in a bit, but before that, I want to highlight the preemptible VMs. Now, preemptible VMs, right, the one which you see over here, see, these are again unique with, in terms of how they operate. These VMs are given to you at a steeper discount, uh, but the catch with them is they can be taken away at any point of time. What do I mean by that? These VMs have a maximum life of 24 hours. Besides that, they don't intimate you if they can take these VMs away from your environment at any point of time. Nutshell, your compute capacity will go away and you will find your VM in halted state. This is how preemptible VMs work. They are really, really steeply discounted. They are generally the additional infrastructure which are not consumed right now by customers. But if a customer is ready to pay on demand or on a committed discount, they take away the preemptible VMs and use them for on demand or committed usage. Right. So that's a least available. Besides that, maximum life for it is 24 hours. Within 24 hours, you will find the running VM in halted state. You can restart and continue with the preemptible VM again. But idea is that compute capacity can be taken away under preemptible VM at any point of time. This is the lowest, costing VM that is available. Let's look at sustained discount. Let me pull this up from the document. All right. So this is a graphical representation of how sustained discounts are applied. So if you're consuming a VM, typically for the whole month, this is the lower axis over here is the percentage of usage during the month. So if you're using it for all 30 days, 31 days, maximum discount what you will get is about 30% on that VM's on demand pricing. The way it works is initial 20% of the usage, right? So let's say the month has 4 weeks, right? First week, there is zero discount. That means you are paying exactly as per on demand pricing. After that, the next 1 week that you use your VM, so about 50% of the month, I would say, you get maybe about 7-8% kind of discount, maybe 10% discount. And then as your usage increases to third week, your discount increases from about 10 to 20% on demand. And if you use complete 4 weeks, you get maximum 30% discount. Now, all VMs don't get 30% discount. Different based on the generation, sub VMs only have maximum 20% discount. But this is the ideology of sustained discounts. You are not committing for it. You are not doing anything to get this particular discount. You're just consuming the VM on-demand billing. And if the VM runs for the entire month, right, you get max 30 or 20% discount on demand. That's how the sustained discounts work. Right? So this is your sustained discount. I was showing this graph. Right? And this is the detail of how it works. All right, that's it. What I wanted to cover in this. Migrate to Compute Engine. This service, right, it helps to move VMs from on-premise to cloud, right? So if you have VM, you can get the Velostrata appliance to run locally in the virtualized environment. It will allow you to migrate existing VMs seamless to the cloud. This kind of a migration is also known as lift and shift migration. So containers are lightweight, virtualization. Many times we refer to this as OS virtualization. So VMs are hardware virtualizations and containers are OS virtualization. They are portable and they can move across different environments and they are scalable. So that's the beauty of containers. To understand about containers, a good idea is to understand why they were innovated. Here on my whiteboard, I have a typical development process. I have a development environment, a testing environment, and a production environment. And let's say, for example, this developer gets a document from his manager which is for a development requirement, and it says that you write the code in Python 2.8, list of functions which are to be built, and he gets a timelines of 100 hours to build it. Let's say that he builds the code, he pushes to the development environment. His colleagues are also all, building the code and writing it over here. And based on his, code, he has to spend the 10 hours making sure that the code works in sync with others. So he spends in the 10 hours over here. His budget of 100 hours, 80 hours were exhausted here. He spends in the 10 hours over here. 90 hours, code moves to testing. Testing is done another 5 hours of finalization of code. In 95 hours, the code is, completed, perfect, goes to production. This is a very ideal scenario, right? You have a budget, you finish it before the time, it's done and over with it. Now, things change when requirements change. Let's say, your security team steps up and says that, we are not going to use Python 2.8, we are going to use 3.1 for it. Now, the requirement has changed, so he has to review the code. Let's say he reviews the code, makes sure that, code works in the environment of Python 3.14 also. And for that, he spends 10 hours of time making sure that, things are aligned with the new version of Python. Now, this code again moves to development. Now, development again, others have also updated their code, so they together again review things. Let's say they spend another 3 hours making sure, that he spends 3 hours making sure that his code works in sync with others' code. And now, it goes to the testing. Maybe another 3 hours of code finalization is required over here before it can go to production. And finally, now again, the code works in production with Python 3.14. Now, in this case, right, I would say it is just that the requirement that changed consumed another 16 hours of developers' effort without adding any other value to the project other than, code now working with 3.14, which was already a working code. Now, what if I could run the same code without modifying it in Python? Even if the environment was running in Python 3.14, my code could run in Python 2.8. Well, that is the idea behind the containers. What containers offers us is if I can isolate the code with its dependencies, its runtime, with a very light OS in it, and it can run in isolation. Now, if it runs in isolation over here, it can run in isolation over here, it can run in isolation over here, and it can run in isolation wherever it goes. This was the ideology behind it. Since its runtime environment, its operating system, everything is isolated over here. It doesn't carry the full OS. It is a very lightweight, abstraction of OS. There is no kernel in it. Kernel it will borrow from the host which it runs on. But that's how the containers are meant to run. So this was a flexibility which the world wanted. That we don't want to rewrite the code until unless there's a real need for it. Just because the environment is getting updated, not necessarily the code needs to be updated. If the library is used by the developer is having an issue and that needs to be updated, because of which you need to do the update, it's a different story. But just because some dependencies have changed, right? You are rewriting everything. That should not happen. So that was a problem which containers wanted to solve. Now this also brought in the ideology of microservices. Now I could take my application into smaller chunks, okay, of services and write them into separate containers. So I can scale the container I want. So let's say it's an e-commerce site and a lot of search is happening today. So more containers of search I can add. And maybe, there is some, maybe a lot of return requests has come in. So return request containers can scale because of, the load over there. So a particular service which is designed and kept in a separate container can scale individually rather than the whole application being scaled. That's another beauty what containers gave us. I hope this helps us understand what are containers. Let's move forward. All right, so let's have a small comparison between VMs and containers. So if you look at it, right, the VMs are full operating systems which run on hypervisors. There are different types of hypervisors you would come across. We have VMware, we have Hyper-V, KVMs, and they all allow multiple VMs to share the same hardware. Versus containers are very lightweight. So, you know, unlike VM, where you would see minimum requirement of a GB RAM, this could be configured with MBs of RAM. You could have a container running with 200 MB very effectively. So that's a good way of doing it. And they share the host OS kernel, so they don't have their own kernel, unlike a VM which has its own kernel. Right? So that's another major differentiator with it. Size wise, this is large, so minimum boot disk which you will come across is at least of maybe 5 GB minimum you would see. Here you could start minimum with 200 MB, 300 MB, and you could see maximum going to a GB depending about what you're copying inside. But they're really very small. Boot time over here, it's in minutes. So whenever your VM boots, it takes at least a minute or two for it to come up. This is like typically starting a service in a VM. So you restart a service, how fast it comes, right? That's the speed you get. Here, they are portable inside a restricted environment. So in the sense is if I have a cluster of physical servers and I'm running hypervisor on top of it, I can move my VM from one server to the other, but it's retained inside the environment. Here, I can treat containers like code. I can upload it to a repository, I can download it, and it can run anywhere it goes because whatever is required, right, in terms of its runtime, in terms of code, everything is sitting inside. So it's a lot of flexibility. Besides that, I cannot upload a VM and share, but here I can do that. So generally, these are developers who make these containers, okay, and instead of running the code, right, code is inside the container and you are now running the container with it. That's how it works. Management, right? It requires management tools like VMware has management tool vCenter, Hyper-V is hypervisor, and the management tool for it is System Center Manager. Now, when it comes to VMs, right, why do we need management? Well, for hyperscalers, large scale operators, right, they have like hundreds and hundreds of physical servers, and which you have like, hundreds and thousands of VM running. So if I have to figure out, right, which VM is running on which server, how many same web servers are running, right? So you need some management layer to figure that out. Same way, when you do containers, you have a similar kind of a problem. You need to provide networking, you need to provide security, you need to provide storage to containers. Along with that, you need to provide management for containers. So I want to understand, how many containers of my web server are running. Now this brings in the idea of microservices also. So unlike a monolithic application where everything is running inside the same server, here application may be made about 15 or 20 different containers also. And then each container can individually scale because the service inside it has more demand instead of scaling the whole application. So management of containers is also tricky, and for that you have Kubernetes, which is built by Google and then handed over to the Cloud Native Foundation, made it public for use, and then Docker has released Docker Swarm for it, and there are a couple of more tools which are there. Docker itself is an open source technology, so we have OpenShift from Red Hat, which is entire Red Hat's version of containers and container management tools. And there are other management tools also in the market. We'll be talking about Kubernetes as such from our exam perspective. All right, so this is what I wanted to cover over here. Thank you. All right, so I just want to bring up one more time, container management. So container management, is needed. Why, right? Why do we need that container management? So, when I am running like a cluster, okay, of computers together, and generally we call them node pool when it comes to, Kubernetes, it's actually virtual machines which are running containers on top of them. Now, if I have to figure out how many green containers are running, or I had terminated all the yellow containers, are they still running or not? I need to understand that, whether this is there. I need to bring them networking, right? So to manage them together, uh, we needed an orchestration service. So Docker released Docker Swarm for it. Google released Kubernetes for it. Okay, and there are other products also there in the market, but these are two very popular ones. Our focus over here will be a bit about Kubernetes. Let's talk a bit about Kubernetes a bit. So Kubernetes was designed by Google, and they handed over to Cloud Native Foundation. So you find, Kubernetes as a container management solution available in all the clouds today. It fully automates deployment and scaling of containers. Right? It allows you to do service discovery, load balancing, and storage orchestration. It is implemented via a simple declarative language, so it becomes very easy for people to adapt and use the containers. With containers implemented through Kubernetes, you get the orchestration server to handle all these nodes. This is your control plane, and this is nodes over here are referred generally as data plane. So when we make any API request to the control plane, it goes over here, and then based on the request, control plane manages and workload around these nodes for us. That's your data plane over here below. Right? That is how containers operate when they are working with Kubernetes environment. So we spoke about containers, we spoke about Kubernetes. Let's understand what is Google Kubernetes Engine. Now, if you have understood containers and we have Kubernetes, then this is really straightforward. Now, when you do containers by yourself and you implemented Kubernetes, you have to manage the Kubernetes master machines, right? You have to make sure that it has a failover in case master fails, right? So you have to do updating, patching. So all that is taken away when you use GKE, Google Kubernetes Engine. This becomes a managed service. Now, after you implement Google Kubernetes Engine, right? Majorly, what you have to worry about is the code that you need to put up in those containers. Rest, all the infrastructure, becomes very straightforward and easy to implement. It automates scaling, updates, monitoring of your clusters, right? It integrates with other GCP service. It's a secure environment for running your containers, right? So all the heavy lifting, right, is taken care by Google Kubernetes Engine for us. So it's efficient in deploying and managing container environments, right? So that's as usual, life is made easy when you go to cloud. That's what Google Kubernetes Engine is again doing over here for us. Well, one challenge going to cloud is that you eventually land up, with one particular cloud provider doing everything over there. But if you don't want to depend on a single cloud provider, I want to run containers and I want to run it in on-premise also, on other cloud providers also, and with Google also. How can I manage this across different infrastructure environments, right? Let's say, we are doing hybrid with on-premise. I want Kubernetes running on-premise. I am using GKE in GCP. I want to centrally manage the entire environment, both in hybrid situation. That is where Anthos comes in. Okay, so Anthos creates that hybrid environment for us for seamless management between the environments. Supports Kubernetes for container orchestration, and you can run this with security and compliance. So you have one place where you're going to control and manage the environment from, and Anthos will help you, do the same thing in both the environments together on premise as well as in GCP. So for hybrid implementation of Kubernetes, we have Anthos available. So you can say Anthos is another layer on top of Kubernetes required when you want to do hybrid container implementation using Kubernetes. Anthos also offers migrate to Anthos as a service, wherein you can migrate your virtual machines to containers. Something which Anthos supports. VMware on Google Cloud Platform. Now, VMware is a very popular virtualization platform in the industry. It has been there since years now, and it is still very popular. Those organizations who have been leveraging on VMware and want to continue using VMware, but still want to leverage on Google Cloud for infrastructure, because maybe they are running out of physical servers where VMware is running. They can do VMware on GCP, and this is done from VMware interface, nothing inside directly GCP interface to see. But with this, you get both. You get VMware environment on GCP, so same services, same solution which you look for, which you're comfortable with VMware will be there. Along with that, you will have native GCP services at your disposal as well. So both the things would be available to you when you do VMware on GCP. Bare metal servers. Now, bare metal servers are dedicated physical servers which are offered by GCP, and this is generally useful, when you have certain kind of licensing requirements. So many products in the industry are such that when you apply a license file or when you activate the license, they detect the physical core, not the virtual core of the VM, the physical core of the hardware on top of which the VM is working. With that, right, what happens is you pay for the entire physical box in terms of licensing fees. For such applications, it makes sense to go for a dedicated physical server and then use the full box. So Google offers this also as bare metal hardware, and they give you full control of the hardware which you are going to pay for. That's your bare metal servers. Coming to Google App Engine. Now, this is one of the oldest cloud service which Google has had, right? So before they came up with the full cloud, App Engine was already there. So this is one of the oldest things which they have been offering. So the idea behind the App Engine was that as a developer, right, you just need to write the code and upload the code. And entire infrastructure, scaling, everything else around it, security, monitoring will be taken care by the cloud provider for you. This was a platform service and still available for us to use. The best part is, as a developer, right, you just need to write the code and you push it. You have some configuration items you do along with it, and you are done. Your program or your application is up and running inside the App Engine service. A very, very powerful service, very good for mobile backend and web applications and stuff like that. So that's what App Engine is all about. It's a platform where you upload the code, leave it rest to the cloud provider to take care of it. Supports multiple languages, common ones, Python, Java, Go, and others as well. Thank you. App Engine has two flavors to be aware of: App Engine Standard and App Engine Flexible. Language support in App Engine Standard is limited to Python, Java, Node.js, PHP, Go, and Ruby. Now, App Engine Flexible supports Docker containers. So, any language of your choice you could use. You could put that into a container and serve it via your App Engine Flexible. So, that takes care of the limitation of language when it comes to App Engine Flexible. Now, here there's a limited customization available in App Engine Standard. App Engine Flexible gives you a better control over the OS, and runtimes can be custom, and whatever you want you could bring in. App Engine Standard does not allow any backend processing. App Engine Flexible does support that. Access to file system in App Engine is read-only versus you get full disk control with App Engine Flexible. App Engine Standard is fast to start up. App Engine Flexible is slower. I want to add on over here, your App Engine Standard can go down to 0 while scaling and only will start when the request comes in, allowing you to only pay once the instance runs. Versus App Engine Flexible will have minimum 1 VM always running. So you're going to always pay for it, irrespectively request is there or not. You can scale beyond as per the load increases, but basic one instance is always going to run for it. App Engine Standard is good for lightweight, fast scaling application. App Engine Flexible for custom dependencies or background processing. When required, you would choose App Engine Flexible. That's it. Another type of popular compute which is doing great nowadays is your cloud functions. So whenever we do application code execution, right, uh, we need to have some server to run on it. App Engine also under the hood is running some compute. And the difference here is when you use cloud function, right, you can define whatever code you want to execute and how you want to trigger that code and just the execution for you. So, and you pay per execution wise. So, moment the code gets executed, you pay for it. It can automatically scale, no patching, no updates, nothing is required from our end, fully managed. You just give the code, set up a trigger, and trigger will execute the things for you. That's how it works. All right, let's very quickly have a look at cloud functions. Now, there are two services which Google offers. One is Cloud Run, another one is Cloud Functions. Now, they are similar lines, and now they have amalgamated their interface also together. So, if you look at Cloud Run, you see the service name over here, and you get two options whether you can deploy a container as a service or a job. Okay, now job basically is to for an event based execution, right? So you provide the container URL for it, give it a name, see how many tasks has to be completed, and container will do the execution of the task provided in the code, and it will then exit, right? So that's a job based execution what we have. The other option is service based execution. So any type of long running container like a web server or something which you want to run for a longer duration, you could put it the service. Whenever the URL gets triggered, the service will get executed. So you can quickly have a look over here also. Okay, so you can provide the sample. You can provide the container URL or use a sample container. Give the service a name. It will generate the endpoint for you to execute the container. Okay, and then that's how it would get triggered. Now, quite a few things under it, but I'm just touching the basics right now. Now, this is your cloud run service where you are running container and the application inside the container. In the cloud function, the only difference is instead of providing a container image, you are actually writing a function in this. You are basically providing a code instead of it. So the code can be inline inside the editor written. It could be coming in from a source pipeline like GitHub, or a container registry also could be used. So you could use that. Uh, Keeping it as it is right now, and I'll just give it a name, demo, and let's say I will select Python for example. Okay, and then we can add different types of triggers, how you want to run this. It can be via PubSub, cloud storage event, right? So someone uploads a file, I want the container to run. Firestore triggers or any other triggers from event, you could use that. So there are different ways of triggering it. Okay. You can set up how much scaling you want around it. So quite a few things around networking also is available. But the idea behind the function is it will get executed based off the trigger. When the trigger happens, the function will work. I can also use the endpoint to trigger the function. That's the idea behind the cloud function. The difference between cloud function and cloud run is in function you provide the code, in cloud run you provide the container image for it. Right? So now the run is restricted to specific runtime environments which are available. So you have Python and whatever other programming language you have, Node.js environment that is there. So there's a few limit of what we can do in terms of functions, in terms of the programming language which we select, versus when we go to container, right, whatever inside the container can be executed for it. So that's how the service differs. Now Cloud Run can use its own compute environment to run the container, or if you have your own Kubernetes cluster running, you could run the Cloud Run container from your own cluster also. Right? So that's another flexibility which it offers. That's it, what I wanted to cover over here. Just wanted to show you how Cloud Run and Cloud Functions look in the console. Apigee. So Apigee is a API management solution. So generally nowadays all the products are designed in a way that they have an API interface to talk to it, and APIs need to be exposed. What Apache offers is a secure way for exposing your APIs, developing it and exposing it, monetizing it, making money out of it is also possible. It's a very powerful service and it allows you to build, integrate, and manage your APIs effectively. That's a bit about APG. Thank you. We are done almost with the compute section. I just wanted to cover a couple of small concepts before we wind up the module. And one of them is microservices. Now we talked about containers, we talked about cloud functions, cloud run. So basically, in today's solutioning world, right, it is very common to design a large application by breaking them into smaller services, and that is where the idea of microservices, right, instead of writing everything in a large monolithic code, each service is separately defined and each separate is separately called based on the request. So this helps to scale individual services. This also has brought in agility that one service at a time can be updated, right, as and when required. Rolling back of the services is much more easier. Implementation is with CI/CD pipeline is much more effective in these environments. So it's a very common solution today to have a microservice-based architecture, and containers is really what it is creating. The feasibility of it to be implemented. With containers, this has become possible that you can define services inside container and containers can scale individually. Now, if you have a large application built out of containers, Kubernetes could be a good place to run your application from. Right? So that's what it helps. For individual services which are going to get triggered by a certain events, right? A good idea is to go with cloud function. So with cloud function, it's completely serverless. You write the code, function gets executed. You already spoke about that, and individual services can work from there. So for a large implementation, you have service like Kubernetes where you get full control on each service, how you want to scale, how many versions of how many copies of that service should run, how it should be load balanced. So that all control you get out of it versus individual services, right? You don't need to worry about clusters and nodes and all with Kubernetes. Just give it to services like Cloud Function or Cloud Run and run it from there. Before we get inside CI/CD, I just want to talk about some products which Google Cloud Platform offers to build and manage CI/CD. First one is Cloud Build. Now, Cloud Build is a compilation tool. So generally, when you write your Java code, right, you need to compile it. You have something locally running like Maven. So instead of you doing it locally and then coming up with a Java archives, you could just upload your code to source repository. From there, it could trigger and go to Cloud Build. Cloud Build will actually build the artifact, send it to artifact registry. From there, code deploy can push it inside your maybe Cloud Run or whatever service you want to use with. So that makes the whole CI/CD process for you. Instead of Java, if you're doing containers directly, right? So if you then in that case, Cloud Build will build your container image. Again, the trigger will be from your repository, and once the container image is built, it will go to container registry, and then code deploy can use that container image to deploy it in Google Kubernetes Engine or Cloud Run or wherever you want to deploy it kind of for it. That's a general structure, and these services participate for that. They all contribute for it. Now we'll talk about why CI/CD and how does it help in the next part. So I just wanted to cover a bit about what is CI/CD and why this is there today. So earlier times, right, we used to have a separate development team and separate operations team. Development team would constantly want to test the code, whereas operations team would be having resistance in terms of changing things inside the environment because that could negatively impact and changes could be either good or bad kind of a situation could happen. To bridge this gap, right, the ideology of CI/CD came in. The idea was if you can continuously integrate and continuously do the deployment of it, the release process would be much more planned and much more easy to achieve. This would assure that changes automatically happen, can be tested, even controlled for manual testing, and when approved can go to deployment process. With CI/CD in place, if things fail, it is easier for you to go back to the previous version of code. Whole thing could be automated. So this has brought in a lot of efficiency in implementation. Development has been much more agile because of it. You can constantly make changes in the environment. Uh, I've come across organizations that implement changes as frequent as once a week in the environment versus, uh, at one point of time, I had seen that releases would happen once a year, in terms of all the releases which are required. So from there to companies who implement CI/CD pipelines, for weekly updates is a transition which industry has gone through. Just wanted to bring this up a bit for everyone. All right, so we are at the end of the module. We have covered compute sections in GCP, Compute Engine, Kubernetes Engine. We spoke about Cloud Run, Cloud Function, bare metal servers, VMware, Microservices, Apigee. Now we will get inside the Q&A section. Thank you. Question number 1. You are program manager within a software as a service company that offers rendering software for animation studio. Your team needs ability to allow scenes to be scheduled at will and will be interrupted at any time to restart later. Any individual scene rendering takes less than 12 hours to complete, and there is no SLA for completion for all the scenes. Results will be stored in global cloud storage bucket. The compute resources are not bound to any single geographic location. This software needs to run on Google Cloud at a cost optimized way. What should you do? Apparently, with the information provided, right, interruptions are okay with it and can be resumed, and output is stored in cloud storage bucket. So this is a clear case scenario where we can implement preemptible VMs. Let's see if we have that in the answer. Option A, deploy applications on Compute Engine using preemptible instance. I guess that's the right answer for us. Other options, deploy application so that it can run on unmanaged instance group, create reservation for minimum number of Compute Engine instance, start more instance with a fewer centralized processing vCPUs instead of fewer instances with more CPUs. So right answer is preemptible VMs. Now there's a term over here which is unmanaged instance group. What is this? I will discuss this at the end of the Q&A. Your company's development team is building an application that will be deployed on Cloud Run. You are designing a CI/CD pipeline so that any new version of the application can be deployed in the fewest number of steps possible using CI/CD pipeline in your design. You need to select a storage location for the images of application after CI part of the pipeline has built in. What should you do? Create a Compute Engine image containing the application. Show the images in container registry. Store the images in cloud storage. Create a Compute Engine disk containing the application. I guess it's self-explanatory. There's not much to add in this. It's container registry. Straightforward, simple. You are a program manager for a team of developers who are building event-driven application to allow users to allow another's activity in the app, to follow another's activity in the app. Each time a user adds himself as a follower of another user, a write occurs in real-time database. The developer will develop a lightweight piece of code that can respond to a database write and generate a notification to let appropriate user know that they have gained a new follower. The code should integrate with other Google Cloud services like PubSub, Firebase, and Cloud APIs to streamline the orchestration process. The application requires platform that automatically manages underlying infrastructure and scales to zero when there are no activities. Which compute resource should your developer select given the requirements? Kubernetes Engine, Cloud Functions, App Engine, Flexible Environment, and Compute Engine. You need something that is serverless, that works on event based, integrates with other services. Very straightforward. That is your cloud function. Cloud function. Your organization wants to run a container based application on Google Cloud. This application is expected to increase in complexity. You have a security need with fine grained control traffic between the containers. You also have an operational need to exercise fine grained control over the application scaling policy. What Google Cloud product or feature should your organization use? I think with all the requirements, right, it is very straightforward. You will go with Kubernetes Engine. Rest all the options will not give you that kind of a control, right? So App Engine doesn't support flexible support, so standard doesn't, and doesn't allow you that kind of control that you're looking for it. Neither does Cloud Run. So I think you're left basically with your option A, Kubernetes Engine. Your company is running the majority of its workloads on co-located data center. The workloads are running on virtual machines on top of hypervisor and either use Linux or Windows Server editions. As a part of your company's transformation strategy, you need to modernize the workloads as much as possible by adapting cloud native technologies. You need to migrate the workloads to Google Cloud. What should you do? Option A, exports the VMs into VMDK format imported in Compute Engine. Export the VM into VMDK format imported into Google Cloud VMware Engine. Migrate workloads using Migrate for Compute Engine. Migrate workloads using Migrate for Anthos. So all four are possible ways of migrations. Okay, you can import the VM, export the VM, and import them into Compute Engine or VMware. Both ways is possible. It is also possible to migrate using Migrate for Compute Engine. The right answer for it is Migrate for Anthos, and the reason is the question is talking about cloud native technology. So it's basically in a way hinting that you want to now move to containers, and that is where Migrate for Anthos works. Your organization runs an application on virtual machines in Google Cloud. This application processes incoming images. This activity takes hours to create a result for each image. The workload for this application normally stays in a certain baseline level, but at regular intervals it spikes to much greater workloads. Your organization needs to control the cost for this application. What should your organization do? Option A, purchase committed discount for the baseline load. Option B, use committed discounts for the expected spike load. Option C, leverage sustained use discounts for your virtual machines. Run workloads on preemptible VM instances. Now, in this question, they have not spoken about capability to handle any kind of interruption. So, since they have not mentioned that, preemptible is out. So, you're left with three options. Now, committed discount, there are two possible options in that which it is pointing out. First one says that for take it for baseline, second one says that committed discount for spike. Now, committed discount is a contract. You sign in generally that and then you use it for a period of time, 1 year, 3 year kind of contracts. So it will make sense to go into contract for baseline load, not for the spike load, because spike load is not going to be always there. Once you pay for the VM in a contract, right, you have to use it ideally for the whole period. Otherwise, it's not utilization of your money appropriately. So you will be going in for a committed discount on the baseline, and you will not be using the preemptible VMs. On spike loads, whatever load comes, you will by default get sustained discount on it. You don't have to do anything. If those VMs work for more than 20% of time in the month, anyways, that is going to get applied. Right. So right answer is committed discount for the baseline load. How do migrate for compute engine and migrate for Anthos differ? Option A, unlike migrate for Anthos, migrate for compute engine assumes that your migration sources VMware vSphere. Option B, migrate for compute engine charges for ingress but migrate for Anthos does not. Option C, migrate for compute engine is closed source and migrate for Anthos is open source. Option D, migrate for Anthos migrates to containers, migrate to compute engine migrates to virtual machine. So the right answer is D. Yes, Anthos for migration is for containers to migrate from VM to containers, and migrate to compute engine is from VM to VM migration. Which Google Cloud product provides consistent platform for multi-cloud application deployment and extends other Google Cloud services to your organization environment? Right. So this is talking about hybrid with your on-premise, and that is where we have Anthos. An organization wants to add new function to their application. They want to write the code and let public cloud provider handle the infrastructure. Which infrastructure solution they should use? A, virtual machine, B, bare metal solution, C, cloud function, D, container registry. I guess it's straightforward, cloud functions. All right, so next question. Your organization needs a large amount of extra computing power within the next 2 weeks. After that, after these 2 weeks, the need of additional resource will end. Which is the most cost effective approach? A, use committed discounts to reserve very powerful virtual machine. B, purchase one very powerful physical server computer. C, start a very powerful virtual machine without using committed discounts. Option D, purchase multiple physical computers and scale workload across them. Well, we need to point out which one is most cost effective. Now, committed discounts is a 1 year contract. So once you enter, you're going to, in a way, commit to pay for it for the whole year. So that doesn't make sense at all. Buying is again a bad idea because you only need it for 2 weeks. So I think the only thing which you have left for is option C, where you get a powerful virtual machine, but you don't enter inside any committed discount contracts. Just use it on pay as you go. After you're done, you can shut down the VM, delete the instance. All right, so this is the last question. A company has been using shared facility for data storage and will migrate to Google Cloud. One of the internal application uses Linux custom image that needs to be migrated. Which of the Google products should you use to maintain the custom image? App Engine Flexible Environment, Compute Engine, App Engine Standard Environment, Google Kubernetes Engine. I guess I have not covered this in the training anywhere so far. So, but just to bring this up with this question, that even custom operating systems can be brought in GCP. You can export this from your environment as a VDI file, import it in Compute Engine, and run it over Compute Engine. So your right answer for this is Compute Engine. We came across this term unmanaged instance group in the Q&A section. What does this mean? Now, whenever we implement auto scaling or we put VMs under the load balancer, we use something called instance group. Now, instance groups are of two types. You have managed and unmanaged. Managed instance group help us with auto scaling, and we can put up with a load balancer on top of it. Unmanaged instance group are in a is a situation where VMs already exist and we directly want to attach them under the load balancer. So that's where we have unmanaged instance group. I just wanted to clarify what these terms were, which were there in the question. Guys, if you have done with module 4, congratulations. If you have any doubts and queries, feel free to leave them in the comments. I will try to answer them as soon as possible. Do like and share them with your friends, colleagues who are looking out for giving Cloud Digital Leader certification. Don't forget to subscribe to my channel. That motivates to make more videos like these. Thank you so much. See you in the next module.